right. Today we're going to be wrapping up this unit. We've been studying all things exponential, all things logarithms. Today we're going to study two special kinds of exponential and logarithmic functions and kind of be wrapping some things up. So the title for today is Base E and Natural Logarithms. So base E is a number. So like pi in the square root of 2, E is an irrational number. So if you were to type E into a calculator or Desmos, it's going to give you a number. It's like 2.7, etc., etc. So we will explore that in just a minute. The exponential function with base e, f of x equals e to the x, is called the natural exponential function, and e is called the natural base. So we got two examples here, and we'll take a look at their graph in just a minute. So f of x equals e to the x. This is the continuous exponential growth. So this word continuous, we're going to be using a lot. And then f of x equals e to the negative x is continuous exponential decay. So it's a special kind of exponential growth, a special kind of exponential decay. Is continuously going. So it's not like different time periods or just this amount of time. It is continuously going all the time. So hopefully you watched the video before this that explained E a little bit better. So let's go see exactly what E is. So if I just type E into, there it is right there. So if you type E into Desmos, it's going to tell you the numeric value for E. E is an irrational number, so 2.718, etc., etc. Let's take a look at the graph. So I've already graphed the continuous exponential growth. That would be the one in the red. And I've already graphed the continuous exponential decay. That would be the one that's in the blue. Notice the shape is just like an exponential growth or just like an exponential decay. This is just a special kind called continuous exponential growth. It still has a wideness up of 0, 1. This one's still growth that I was playing around with here. And then this one is still decay. I still can go through and do domain and range like we did before with any kind of graph. So my domain for both of these are negative infinity to infinity, and my range for both of these is anything greater than or equal, anything greater than 0. It can't equal 0 because there's an asymptote there. So this is just going to keep going on and on and on. It gets closer and closer to the x-axis, but it's not going to touch. It's an asymptote there. Now, just like we've been studying exponentials, there's an inverse for continuous exponential growth, and that is called a natural logarithm. So I'll give you a second to write this down. Pause, of course, if you need to. So the inverse of a natural base exponential function is called the natural logarithmic function. Now, it is not represented in L. It is represented LN. So again, it is kind of backwards. I believe it's from like a Latin word. So you might think their abbreviation should just be NL, but it's not. It's LN. So this is y equals the natural log of x. A little bit of background just because I like for you to know where stuff is coming from. The natural log of x is the same as log base E of x. But you wouldn't see this log base E of x over time. Mathematicians have just changed this log base E to natural log. So you wouldn't see this, but I do want you to see the connection there so that maybe you can see that E and logs are inverses of each other. It's just a special kind. So again, log base e to the x is the same as the natural log of x, but you wouldn't see it written. You would just see the natural log of x. So let's see what this function looks like in Desmos. So here it is right here. So to find these functions, so I had already pre-typed them into before I started the video, but if you go underneath functions, MISC in your Desmos, you'll see the LN button where my pointer is moving. You'll see the regular log, you'll see your log base E and all that good stuff. So I've already typed this in and there it is. This looks just like a regular logarithmic function. It's just a special kind. So that's all that we're doing today. We're looking at a specific type of logarithmic function called the natural logarithm and looking at a specific type of exponential growth called continuous exponential growth. Now I'm going to get rid of my decay one for just a minute so that I have this. These two functions are inverses of each other. So regular exponential, regular log are inverses, and these two special kinds are inverses of each other. So inverses reflect across the line y equals x. So if I put y equals x in here, you kind of can imagine, hopefully, this red e function being flipped over the diagonal line to make this green function. So inverses reflect across the diagonal line y equals x. Everything we know about this function here is just the opposite. So this point is 0, 1. So this point here is 1, 0. So everything has just been flipped. For the red function, my domain is negative infinity to infinity. For the green function, my range is negative infinity to infinity. So notice it switched. For the red function, my range is y greater than 0. For the green function, my range is my domain is x greater than 0. So everything that we know about the red function, flip it inverse for the one in the green. Since these two functions are inverses, I can use these two to help us solve equations. So if I see a problem that has an e in it, we're going to take the natural log. And if I see something that has a natural log in it, we're going to base e both sides. So hopefully you have all this written down in your notes. As always, pause the video if you need to. And we're going to get into some examples solving continuous exponential growth and logarithmic equations. So here we go. Of course, your goal is to get e by itself. Your goal is to get x by itself, and we're going to do that by getting rid of the e that's in the problem. So first one, 3e to the 4x minus 12 is equal to 15. So we're going to go through. We're going to add 12 to both sides. The opposite of multiplying by 3 is to divide both sides by 3. Now, here is the new piece for today. So up to this point, nothing was new. We already knew the opposite of subtracting is you add. We already knew the opposite of multiplying is you divide. So when you see an e, you're going to take the natural log of both sides because they're inverses. So I'm going to take the natural log of this side, and I'm going to take the natural log of that side. So when you see e in the problem, take the natural log of both sides. Again, this is an ln. You might be tempted to put nl, but that's not the case. We use ln. Now, since these are inverses of each other, the natural log and e are going to cancel out because they are inverses of each other and they make the number 1. So that cancels. So we're left with 4x equals the natural log of 9. We're trying to get x by itself, so divide both sides by 4. So x equals the natural log of 9 divided by 4. And we can type that in Desmos and get a decimal approximation. So when I type this in Desmos to get my approximation, I'm going to get rid of this and get rid of this. We are doing the natural log of 9 divided by 4. And let's round to the nearest hundredth, so that would be 0.55. So 0.55. So we have our exact answer. So this one at the top would be the exact answer. And this one down at the bottom would be an approximation, depending on what our answer choices specified that they wanted. If they wanted the exact answer, we put in natural log of 9 divided by 4. If they wanted us to round to the nearest tenth, nearest hundredth, it would give us 0.55. Okay. So I may not go through and type in each one in Desmos, but just know that Desmos is here for you to type it in and get your decimal approximation. All right, number 2. Again, we're going to go through and solve this problem. We're going to subtract 8 from both sides. So that's going to give me 4e to the negative x is equal to 9. Divide both sides by 4. So e to the negative x equals 9/4. I got a fraction, but that's okay. New piece for today. If you see e in the problem, you're going to take the natural log of both sides. So I'm going to take the natural log of this side, and I'm going to take the natural log of the right-hand side. Inverses cancel. Adding and subtracting cancel. Multiplying and divide cancel. Square root and square cancel. So natural log and e are inverses. They're going to cancel because they make the number 1. So I have negative x is equal to the natural log of 9 divided by 4. And we need to divide everything by negative 1. So my final answer would be x equals negative natural log of 9/4. So x equals negative natural log of 9/4. So notice how similar the two answers are here, but notice I am going to type this one in, but notice when you type it in, the answers are going to be different. So when I type this in Desmos, it's going to give me negative natural log of 9/4. That's what I'm typing in. So we'll come over here, negative natural log of 9/4. So if I round a little bit to the nearest hundredth, I got 0.81, a negative 0.81. Okay. So hopefully you're doing well as you're following along. So notice how similar the numbers were. The first one was natural log of 9, all divided by 4. This one is negative natural log of 9/4. So the placement of your numbers and what you're multiplying or dividing does make a difference. Now let's go through. We've done a couple of problems where I started you off with E. Now I'm going to start you off with natural log, and we're going to have to exponentiate both sides. So we're working the opposite direction. So here are 3 and 4. All right. So 5 times the natural log of 6x is equal to 8. So we want to divide both sides by 5 first. We're going to get a fraction. That's okay. So the natural log of 6x is equal to 8/5. So this was 5 times the natural log of 6x. I divided both sides by 5. Now, new piece for today. If you see ln, which is our natural log, we're going to exponentiate both sides. And all that means is to base e both sides. So I'm going to base e this side so that e is my base and whatever I had became my exponent. And this is an 8. Okay. So whatever we had, we're going to base e both sides. So that process is called exponentiating. So if you see natural log, you're going to make it be a base e. Now we'll go through. E and natural log are inverses of each other. So we have 6x equals e to the 8/5 power. And the opposite of multiplying by 6 is to divide. So x equals e to the 8/5 all divided by 6. So e to the 8/5 all divided by 6. And we'll do our thing over here in Desmos. We will type that in. Desmos does recognize e as the natural number, so you shouldn't have to do anything special to get there. So e to the 8/5, and that is all divided by 6. So we round to the nearest hundredth, 0.83. So 0.83. We got our exact answer, and we got our approximation. So 0.83. Why was on my mind? Because I don't think I've done it yet. If you type in, okay, so this is what I've been saying. I've been telling you that natural log and e are inverses, so they cancel. So I just wanted to explicitly show you that they make the number 1. So the natural log of e is 1, and if I go the other direction, this one you're going to have to get a number, so never mind. Okay, there it goes. So, and both ways are going to cancel out, and you'll be left with the number 1. So just showing you that inverses cancel. So the stuff that I have in a red where I marked out the e and the natural log, that's why they cancel out, because they make the number 1. And we know anything times 1 is whatever that number is. Okay, number 4. 2 times the natural log of 5x is equal to 6. We're going to start by getting rid of this number. So we're going to divide both sides by 2. So that's going to give me the natural log of 5x is equal to 3. Now we're going to exponentiate both sides. So base e. So e natural log of 5x is equal to e to the 3rd. E and natural log cancel each other out. So cancel, cancel. So we're left with 5x equals e to the 3rd. And the opposite of multiplying by 5 is to divide. So our final answer is e to the 3rd divided by 5. And this one, I trust by now you know how to type things into Desmos. So when I type this into Desmos, if I round to the nearest hundredth, I got the following decimal approximation. So make sure you can accurately get that one as you're working at home or wherever you may be watching this video. Okay, I want to take a look at one more. So number 5 down here at the bottom, I have the natural log of 2x minus 3 to the third is equal to 6. So I cannot start by adding 3 or dividing by 2 because this is all in parentheses and it's to the third power. So we are going to go ahead and start this problem by exponentiating both sides. So base E over here and base E on the other side. So exponentiating just means raise each side. Each side has a base of E. E and natural log cancel each other out, so I'm going to cancel these two. So we're left with 2x minus 3 to the third is equal to E to the sixth power. From here, I can take the cube root of both sides and we can cancel some things out. So I can take the cube root of both sides. It's going to give me 2x minus 3 is equal to E squared. So I canceled out some of the exponents there. From here, I can add 3 and divide by 2. So add 3. And I can divide by 2. So x equals E squared plus 3, all divided by 2. Oh, sorry there. Let me slide up for you. So I added 3 to both sides and divided by 2. And when you type that into decimals, round it to the nearest hundredth, this is what you should get. So the exact answer would be E squared plus 3 divided by 2. And as an approximation, it'd be 5.19. In the next video, we'll take a look at some word problems talking about continuous exponential growth. And there's a formula that we'll also be using to help us solve some of these problems.